everyone, let's talk about the real-world applications for complex numbers, aka word problems. So what we're going to do is read through the problem and highlight key information that will help us solve each problem. Number 1, sign errors. Jennifer and Jessica came up with different answers to the same problem. They had to multiply 4 plus I, my highlighter, not my pen, 4 plus I times 4 minus I and give their answers as a complex number. Jennifer claims that the answer is 15 and Jessica claims that the answer is 17. Who's correct and explain? So first things first, we know a complex number, if we're trying to write our answer as a complex number, it's either going to be a whole number or it's going to be in the form A plus BI, right? Now we know 4 plus I and 4 minus I are complex conjugates. So we're not going to get a complex number in the form A plus BI. We're going to get a whole number. All right, we're going to get a number because they're complex conjugates. So what we want to do is let's multiply it out. All right, 4 plus I times 4 minus I. So first, outer, inner, last. And when we do that, we end up with 4 times 4 is 16. 4 times negative I gives us minus 4i. I plus positive 4 plus 4i. I times negative I gives us negative I squared. All right. Now, we know I squared, right? Our key fact, I squared equals negative 1. Key fact we've got to have memorized. And then we know that the negative 4i and positive 4i will cancel out. So we're left with 16 minus I squared, and we can replace the I squared with negative 1. So we're left with 16 minus negative 1, which is 16 plus 1, which gives us 17. So, and the error that Jennifer probably made, if she thought it was 15, she replaced the negative I squared with just negative 1. She didn't realize that it was minus a negative 1. All right, which is an easy mistake to make. So we've got to always be careful and remember that we're just replacing the I squared with negative 1, and we can't forget about that negative that was in front. All right, number 2, we're talking about electrical engineering. So alternating currents, AC, in an electrical circuit can be described by complex numbers. In any electrical circuit, Z is the impedance in the circuit is related to the voltage V and the current I. And it's by this formula right here. Z equals V over I. So impedance equals voltage divided by current. The standard electrical voltage in Europe is 220 volts. All right, so we know that voltage V equals 220. So in these problems, use V equals 220. So I didn't even need to write that. So part A is asking us find the impedance, and we know the impedance is our Z, so we're looking for Z in a standard European circuit if current is 22 minus 11I. So I is 22 minus 11I. So we're using our formula. Z equals voltage divided by current. We know voltage is 220. And we know we're given that our current is 22 minus 11I. Now we can't have I in the denominator, so our goal is to get I out of the denominator in order to simplify this answer. First thing we can do is simplify everything though. We can take out a GCF of 11, right? So if we take out 11 from the top, we end up with 20, all right? And if we take out 11, factor out 11 from the bottom, we end up with 2 minus I. So then what we can do is the 11s cancel out, and we're left with 20 over 2 minus I. Now, in order to get rid of the I from the denominator, we have to multiply top and bottom by the complex conjugate. So we want to multiply top and bottom by 2 plus I. And when we do that, on top we've got to distribute the 20 to both both terms. So we end up with 40 plus 20i. And then on the bottom, we FOIL it out. So we end up with 4 plus 2i minus 2i minus I squared. Then we keep simplifying, so we end up with 40 plus 20i over, the 2i's cancel out, 4 minus negative 1, right? Because we can replace the I squared with negative 1. So we end up with 40 plus 20i over 5. And then we can simplify everything. So we can do 40 divided by 5 gives us 8 plus 4i, right? We're dividing both terms on top by 5. And that's our answer for part A, 8 plus 4i. Now going back to part B. We want to find the current, so we're looking for I in our formula, Z equals V divided by I. In the standard European circuit, if the impedance, so if Z is 10 minus 5i. All right, so now we plug it into our formula, right? Our formula is Z equals V over I, right? This formula, right? Same formula, right, as this one up here. So we know Z is 10 minus 5i equals voltage, we know is 220, and we're looking for current. Now we want to think of this as proportions, all right? We can just put this over 1, and then we can cross multiply. All right, so if we cross multiply, right, and multiply that out like that, we end up with I times 10 minus 5i equals 220. Now our goal is to get capital I, right, the current, all by itself. So divide both sides by 10 minus 5i. Those cancel out. And we're left with I equals 220 over 10 minus 5i. Now we can't leave that as our final answer because we cannot have I in the denominator. So we want to start by factoring out a GCF. So we can factor 5 out from here. All right, if we factor 5 out, we end up with 5 times, what is that going to be, 44 over 5 times 2 minus I. 5's cancel out, and we're left with 44 over 2 minus I. Now we've got to get rid of the I from the denominator, so multiply by the complex conjugate since it's a binomial in the denominator. So multiply both sides by 2 plus I. Now, we've got to distribute the top, so we end up with 88 plus 44i over 4, because 2 times 2 is 4, then we end up with positive 2i minus 2i, and we know those are going to cancel out, minus I squared. So still leave the top the same as we simplify the bottom. Over, those cancel out, and we're left with 4 minus I squared, which we replace with negative 1. So we get 88 plus 44i all over 5. Now, we still want to simplify this, so we plug it into our calculator, and 88 divided by 5 is going to give us 17.6, and then 44 divided by 5 gives us 8.8i. And that would be our final answer for part B. Now, moving on to part C. We want to find the impedance, so we're looking for Z in a standard European circuit if the current is 20I. So I is 20I. So we use our formula Z equals voltage over current. We're looking for Z. We know voltage is 220, and we're saying current is 20I. Now here we can just simplify this down, so we can take out a GCF of, let's see, we can take out 2, right? So if we take out, or actually we can take out 20, right? If we take out 20, we end up with 11 on top, and if we take out 20 here, we end up with I. So 20's cancel out, and we're left with 11 over I. Now we've got to get rid of the I from the denominator. So we multiply top and bottom by I. And then we end up with 11I on top over I squared on the bottom. 11I on top, and we replace the denominator with -1 because that's what we replace I squared with. And then we just end up with negative 11I. And we're talking about amps, so it's negative 11I amps. And also, I forgot, going back to part B, right? Part B, we're talking about, we're solving for I as well. So we're trying to find, the current, and we know that current is also going to be amps as well. All right, so this should also be amps for part B. All right, so I know that one was a lot of work, and I don't know how you guys fit it in on your paper. If you needed extra paper, I apologize. But if you have any questions, please raise your hand and ask. Otherwise, look to the board to see what to do next, and I hope that you have a great day. Bye.